All right, welcome back to introductory mathematical analysis A. We are still in chapter 12. Chapter 12. This time around, we are going to be covering chapter 12.7. Okay, 12.7, which is the higher order derivatives. Higher order derivatives. Okay, for now, we are not going to cover the implicit higher order derivatives. We are only going to be dealing with higher order derivative without the implicit differentiation. Okay, let's go. Now, in this higher order derivative, we are used to y prime, or we say f prime of x. All right, or we say dy over the x. Of course, you know it's not always going to be dy over the x all the time. You can have the p over the q. You can have the y over the t. So, but they are still first order. All of them, they are still first order derivative. That is what we call first derivative or first order derivative. First order derivative. Okay, now, apart from the first order, we can also have what we call the second order derivative, where you derive the second time, second order derivative, and that is given with this notation, y prime prime, or you say f prime prime of x, or you say this 2y over the s square. Okay, you write this. If you want to write in this form, then we write like this. All right, please take note of that. There are other forms that we can still write, but for your level, let's just stick to this for now. All right. Now we have third order derivatives. So for the third order, we have y prime prime prime. We have s prime 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 of x, f prime 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 of x. We have the 3. Take note that the 3 is on the d at the numerator for y, and at the denominator is on x. Okay, please take note of that. Of course, the square y we can also have for f of x. You can also have the square f of x all over the s square. Okay, you can also have like that, or you simply write d square over the s square f of x by this side. Still fine, it's still the same. All right. Okay, so we have the third order. You can also have the fourth one, the fourth order derivative, fourth order. In the fourth order, there's no prime prime now, then you need to use a number. From the fourth one, you need to use a number 4. Okay, f of 4 of x. Okay, from the fourth one, you don't say y like this. No, we don't use this. We use this 4 now from fourth one. So fifth one will be this. Okay, and like that, this still remain for the fourth one, 4y over ds4. For the fifth one, for d5 all over ds5. Okay, like that. Okay, please take note of that. So all what we need to do here is just to derive again. The derivative of the first one, you derive it again. making the second order derivative of the second one you derive again, making the third order like that. Okay, let's take examples. Okay, so we have if f of x is given as 6x3 minus 12x squared plus 6x minus 2. Okay, so we want to find y prime. Okay, not y, because we are given in terms of f of x, so that will be f prime of x. Okay, that's what we want to find. So let's go to find that. The first derivative is what? That will be 18x squared minus 24x plus 6. That is the first one. The second derivative will now be, this will now be 36x minus 24. What about the third derivative? That will be 36. Okay, that is all. Okay, that's what they want us to find. And you see, we just derive the first one again and derive the second one again, and then we get that. Of course, now if you want to find the fourth one will now be, if you want to find the fourth one will just be 0. So from the fourth one, we get 0. From the fourth one, we get 0. Okay. And the fifth one will also be 0. The fifth one will be 0, like that. Okay. Please take note of that. It's just to derive again and again to get as many other derivatives they want you to find. All right. Let's take another example. Example 2. If y equals e x is plus 2. Let's write this e very well. E x raised to the power 2. Okay. What do we want to find? We want to find the square y over the x squared. Okay, we want to find the second order. We are just finding the second order derivative. Okay, the first order derivative will become what? This is e x squared multiplied by the derivative of this, which is 2x. Okay, that is the first order. The second order now, the second order derivative. Now, in doing the second order, this is a product rule now. This becomes 2x e x raised to the power 2. Okay, this becomes a product rule. So you can hold on to this. You can either write it this way and this one making u and this one making v, and then you use your product rule, or you can bring this constant out and do something like this. Yeah, and then this constant will just be there, and later it will multiply everything. Any one you want to do is still fine. Okay. All right. I'm just going to hold on to this together with this one. So I hold on to this 2x. I differentiate this. I will have is multiplied by 2x again. Okay, multiply by 2x. Then plus, I hold on to this, multiply by, then multiply by this. This gives us what? This gives us 2. Okay, so now I simplify 4x squared e x squared plus 2e x squared. Okay, all right, you can factorize out that e x squared. Then we have 4x squared plus 2. Okay, that is it. Please ensure that you understand how to go about it or how we have done it. Okay, that is fine. Let's go to another example. Example 3 now. Example 3. In example 3, if f of x equals to x ln x, okay, we want to find f prime 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 of 2. Okay, that's what we want to find. We want to find f prime prime of 2. All right, you will observe that this is x multiplying by ln of x, and that gives us a product. So we use product rule for that. F prime of x, product rule, hold on to this, differentiate this, plus hold on to this and differentiate this, will be 1 multiplied by ln of x. Okay, that one gives us 1 plus ln of x. Okay, that is the first product. That is the first derivative rather. Let's go to the second derivative. Second derivative. We are going to the third one. We are going to the third order derivative. So this is 0. Of course, this is 0. Then this will be 1 over x. Okay. That is the second derivative. Now let's go to the third one. Third derivative. In third derivative, this is same thing as minus 1. Okay, so you can have minus x minus 2. Okay, that will give us minus 1 over x squared. Okay, that is the third derivative. And they want us to find the third derivative at 2, at x equals to 2. At x equals to 2. So the third derivative at x equals to 2 becomes 1 minus 1 over 2 raised to power 2, which will give us minus 1 over 4. Okay, that is the one. That is for that. Please ensure that you understand. Okay, another example. This is example what? Example 3. Let's go for example 4. Example 4. In example 4, we are given if y equals to e raised to power 2x plus e raised to power 3x, find the 5y over the x5 at x equals to 0. At x equals to 0. At x equals to 0. Okay. All right. To find this one, again, we find the first derivative, which is dy over dx. That one gives us 2x multiplied by 2 plus e3x multiplied by 3. So we have 2e 2x plus 3e 3x. Okay, that is the first derivative. Don't forget we are going to the fifth order derivative, fifth one. Okay. All right, the square y now over the x square gives us now 2e multiplied by 2 again plus 3 multiplied by 3. Okay, that simply gives us 4e 2x plus 9e 3x. Okay, that is fine. Let's go to this third one, 3y over dx3. Again, of course, you should have known the pattern for now, by now. So, but let's just write it again. Multiply by 3. Okay, this simply gives us 8 e2x plus 27 e3x. Okay, that's fine. Then we go to the fourth one. We go to the fourth one. That will give us 8e2x multiplied by 2 again, plus 27e3x multiplied by 3. Okay, what do we have in that one? What do we have in that one? This is 16e2x plus this is 1, that is 21, 81. So that is 81 e3x. Okay, that is fine. And then the last one there, d5y over ds5. Again, gives us this multiplied by 2 plus 81 multiplied by 3. Okay, this gives us 32 e2x plus this gives us 3 and 2, 4, 3 e3x. Okay, that is it. We are done with our derivative. Then we need to find it at 0. At 0. So d5y over dx5 at x equals to 0. That will give us 32 e0 plus 243 e0. Okay, and this is 1, this is 1, so 32 plus 243. Of course, that will give us 5, 7, 275. Okay, please take note of that. Ensure that you understand all the derivatives we have done. All right. Okay, another example. Okay, so example, I think example what now? This example 4. Okay, example 5 now. Example 5. If y equals to e2 ln of s squared plus 1. Okay, find y prime prime when x equals to 1. Okay, all right, if you look at this one now, you should recognize something. All right, if you recognize this, it's fine. If you don't recognize it, you just derive it the way it is. So, but you can recognize that this is equal to this ln s squared plus 1 raised to power 2. This is that. Okay. If you recognize that, that will be fine, because that will make your work simple, and then you can have s squared plus 1 raised to power 2. If you recognize that. If you don't recognize that, just derive with your exponential function. It's still fine, but only that it will take you more time to do so. Okay, so we have this. So derive this. If you derive this, then that will become 2s squared plus 1 minus 1. Okay, so which is 2s squared plus 1. Okay, now derive the second time. Multiply by inside. Sorry, we are supposed to multiply by inside. Let's multiply by the derivative of inside. Then we multiply by the derivative of inside, which is 2x. Okay, so this gives us 4x x squared plus 1. Okay, that is fine. Now we want to derive the second time. Now this becomes a product rule, but because the power here is just 1, you can multiply inside. Although you can still use product rule to just multiply, but because the power is 1, just multiply inside and make things easy for yourself. So we have 4x3 plus 4x. Okay, that's what we have. Oh, sorry, this is just exactly that, 4x3 plus 4x. Okay, that is that, not the derivative. This is not the derivative. We are just writing this one like this because it can be multiplied out easily. All right, so now let's now go to the derivative now. In the derivative is just 12x squared plus 4. That is it. That is it. Now you put x equals to 1. So my y prime prime at 1 is 12 x raised to the power 2 plus 4, which is 12 plus 4, which is 16. All right, please. Sometimes you need to use the law of logarithm to simplify your expression before you derive, like in this case. But if you don't recognize that this you are supposed to do the way I did now, it's fine. Let's just put it along with us and see what we are going to get now. So we have so we have e ln s squared plus 1. So when we have our y equals to e2 ln s squared plus 1. How do we derive this? In case you don't recognize it. So y prime becomes what? Write this the way it is. Okay, this is 2. Okay. Multiply by the derivative of the power. The derivative of the power. What is derivative of the power? 2 over s squared plus 1 multiplied by the inside 2x. Okay, multiply by the inside 2x. Okay, that's what we have there. That is what we have for the first derivative. For the first derivative, so this becomes e2 ln s squared plus 1 multiplied by 4x over s squared plus 1. Okay, that's what we have for the derivative. Now you need to find the second derivative. Find the second derivative. Okay, to find the second derivative, this now a product rule, which I can write like this. Is now a product rule, which I can write like this. Okay, so in order to multiply this, you need to hold on to this, differentiate this, then hold on to this, differentiate this. Okay, the differentiation of this is just exactly what we have here, only that this is what we need. Okay, so I hold on to this. Okay, this is 2. Then I'm differentiating this. To differentiate this, we just have the same thing as we have here. E2 ln s squared plus 1 multiplied by 4x over s squared plus 1. Okay, that's the derivative of this one. Then plus I hold on to this, and then I derive this. To derive this, we're going to have, this is the numerator, you derive that one first. You derive the numerator first. So we have 4 multiplied by s squared plus 1 minus the derivative of this 4x, you write that one like that, then you derive that one 2x. Okay, all over x squared plus 1, all what? All square. Okay, that is it. You see now it's looking a little complicated, but that is it. All right. Let's try to write it properly. 4x over s squared plus 1. That's multiplied by the whole of this one. Okay, plus this is now 4 s squared plus 4. Okay, minus 8s squared. Okay, all over s squared plus 1 all square. Okay, this is 2 s squared all over that. Okay, so that's what we have there. Then you need to substitute the value at 1. So y prime prime of 1. Okay, y prime prime of 1, this is 4 over 2, 4 over 2, like that. This is 1, this will be e2 ln of 2, ln of 2. Okay, multiply by again 4 over 2 plus, okay, this will give us this one up, supposed to actually give us, this is minus 4s squared plus 4. So it's supposed to give us that. So if you put 1 there, this will be 1. This will be 4 minus 4 plus 4. That will be 0. So it will be 0 over s squared plus 1 square. Okay, this which will be 0, which will be 0. All right. So we are going to now be having, this is 2 multiplied by another 2, then multiply by ln of 2. Okay, that will be 4 multiplied by 2 ln of 2. Okay, that is what we are going to be having. But you can see that when we simplify, we just get this. Of course, this also supposed to give us 16. All right, so make sure that you understand the way it is done. Thank you.